Alright everyone, welcome to my first video. This video starts off our introductory unit, and the lesson for today is on measurement. Now, if you asked me what my height was, and I told you it was 3, that would be a pretty useless measurement to give you, because I haven't included any units. You'd probably be wondering, am I 3 feet tall? Am I 3 meters tall? Am I 3 light years tall? It's not very useful for me to give you a number without units when we're talking about measurement. So whenever we talk about measurement, it's important to talk about units. And measurements in physics are usually carried out using what we call SI units. Now, this is a collection of units that most of the world decided we should use. It was given a French name. SI stands for Système International. But you probably know it more commonly as the metric system. Now, let's just quickly go through some of the main units that are part of the metric system. In the metric system, we commonly measure length using meters, the symbol for which is just a lowercase m. Mass is measured using kilograms, which have the symbol kg. Time is measured in seconds, not minutes or hours, which has the symbol s. Speed is measured in meters per second, so it's a combination of our length unit and our time unit. And the symbol we give for meters per second is the symbol for meters, the symbols for per, which is a fraction, and the symbols for second. Now, it's good practice to write units like this as a fraction because it reminds us that it's something divided by something else. But you will commonly see people write this with a slash instead, like so. The units for acceleration, if you can reach in your brain way back to the depths of when you did Science 10, are this funky unit called meters per second squared. Which has the symbol meters per second squared. Now, here are a couple of units that you probably haven't seen yet in school. The unit for force is named after a guy who is rumored to have discovered forces when he was sitting under an apple tree and an apple fell on his head. You might remember this guy's name is Newton. And that's exactly the unit we use for measuring force. And the symbol for that is just his first initial. Energy is measured in units called joules, which have the symbol capital J. Now, if you asked me how much time was left in physics class before lunch, and I told you, oh, about 900 seconds, you'd probably roll your eyes at me and say something like, come on, give me a more useful unit. To which I might reply, but I'm using seconds. This is the metric system. It's the base unit for time. I'm using the Système International. Come on, get with the times. Everybody uses this. But you'd have a point, because even though this is a metric unit, it's not very useful for defining that sort of length of time. And to deal with this problem, we have ways of sort of modifying all of these units to make them bigger or smaller to fit our needs. So to make life easier when dealing with really small or really large numbers, we use what are called prefixes. So this gray line here represents our base unit, one of the units from the table above. Could be a meter, could be a second, could be a joule. And if we want to make that unit a little bit bigger, so we can use it to describe bigger things, we add one of these upper prefixes to it. And the first prefix we might go to is the prefix kilo, which has the symbol lowercase k. And this prefix means basically 1,000 or 10 to the 3. So a kilometer is 1,000 meters. A kilogram is 1,000 grams. A kilosecond, although it's not a term we use often, is 1,000 seconds. Moving up the table, if we wanted to describe something even bigger, we might use the prefix mega, which has the symbol capital M. And mega represents 10 to the 6, or 1 million of something. Next up is giga, which means 10 to the 9, or tera, which means 10 to the 12. Now note that these prefixes all go up with the exponents increasing by 3 every time. 3, 6, 9, 12. If we want to describe something that's smaller than one of our base units, so smaller than a meter, or smaller than a second, or smaller than a joule, we'll use one of the prefixes that are down here on our table. The first one we'll go to is centi, which is defined by a lowercase c. This unit, or this prefix, is sort of the odd one out because it doesn't follow this rule of 3. Centi represents 10 to the minus 2 of something, or 0.01 of something. As a quick refresher for you, if you want to write an exponent of 10 as a decimal, you start with a 1. Now, normally the decimal would be here, but since we have a power, or an exponent, of positive 3, we're going to move the decimal to the right 3 places. So, 1, 2, 3. And our decimal will end up here, which means we've got 3 more zeros that have been added, giving us the number 1,000. On the other hand, in this example down here, we would start with the number 1, which would have the decimal here. And this time, we're going to move the decimal to the left 2, because our exponent is negative 2. So 1, 2. Our decimal would end up here, and we end up with 0.01. Finishing up our table now, the next prefix is milli, which is 10 to the minus 3, or 0.001. Next is micro. Now, we'd be tempted to use a little m here for micro, but we already used m again, so we're going to borrow a letter from the Greek alphabet. This is the letter mu, and it's written like a U with a funky tail on the front-hand side. And mu, or micro, represents 10 to the minus 6 of something. So a micrometer would be 10 to the negative 6 meters, for example. Next is nano, 10 to the minus 9. And finally, pico, 10 to the minus 12. Now, there are prefixes that go even further down and ones that go even further up, but these are the ones that I've decided to give you for now. A couple things I want to point out here. These are all capital letters, or uppercase. And these, the rest of them, are all lowercase letters. Don't ask me how K got grouped in with the lowercase rather than the uppercase. I don't know. It drives me crazy, but that's just the way it is. And it's something we'll just have to deal with and struggle through. Another thing I'd like to mention is that these 3, I expect you to have memorized. That's not to say I wouldn't give you a problem with some of these other ones on it, but if I did, you'd have a formula sheet or a reminder that would tell you that, for example, giga is 10 to the 9. But kilo, centi, milli, these are ones you guys should all absolutely know. Now, sometimes, although we hate to do it, we have to leave the world of SI units, of metric units, behind, because there are just a couple of units that are used so commonly that even though they're not metric, they've kind of forced their way into our lives. And the biggest examples of these are a couple of time units, which you're very familiar with. And these are the minute and the hour. And in case you've forgotten, 1 minute is exactly 60 seconds. And 1 hour is exactly 60 minutes. Now, Although it may not seem like the most glamorous of tasks, it's extremely important to know how to convert one quantity from one unit to another. To realize the importance of being able to do this, you need look no further than Google. A simple internet search for unit conversion failures yields tons of examples, from losing multi-million-dollar spacecraft because they crashed into a planet, to airplanes that run out of fuel in the middle of their flight because the people who filled it up with fuel were using the wrong units. So while it's not always the most fun calculation to do, the calculation of converting units can be extremely, extremely important. To do that calculation, there's a series of steps that I like to follow. And these might be different from steps you've learned in the past. The reason I display things this way is because, to me, it really helps solidify the importance of fractions when we're talking about unit conversions and being able to write things as fractions. So here goes. As I tell you the steps, I'm going to work through the first example with you. So the first thing to do is to write the quantity you're starting with, including its units, as a fraction on the left side of your page. So down here, the quantity we're dealing with is 165 millimeters. And I want to write that as a fraction. Now, as a quick reminder, something that doesn't normally look like a fraction or look like it needs to be written as a fraction can always be written as a fraction by simply putting it over 1. The next step is to write the units we want to get to, also as a fraction, on the right. The next step and final step is to multiply this stuff on the left here by one or more conversion factors, which will look sort of like this. And the thing to know about conversion factors is these are just fancy looking number ones. Now, as another reminder on how fractions work, there are many, many different ways you can write the number 1 as a fraction. One simple way would be like so. 1 over 1, which equals 1. You could also write it like this, which is also equal to 1. You can really pick any number you want. If you write it over itself, it's going to be equal to 1. And we can perhaps extend this a little bit further. Maybe we don't even have to use numbers. Maybe we could use random symbols. Or we could take it a step further, and we can even use two things that, although they don't look like they're the same thing, they actually are. Now, bear with me here. This is maybe a bit of a stretch, but I'm going to argue that Spider-Man divided by Peter Parker is actually equal to 1. Because although these two things look different, they're spelled different, you and I both know that they're actually the exact same thing. So when you divide them by each other, it gives us 1. Now, this is the key to writing in these conversion factors. But first, let me backtrack for a second. I've got millimeters on the top over here, but I don't want millimeters. I want just meters. So I need to get rid of these millimeters. Now, fortunately, when we're multiplying fractions by each other, we know that something on the top can be gotten rid of or canceled out if it also appears on the bottom. So if I put millimeters down here, then I'm going to be able to cancel those out. And remember, this only works when we're multiplying fractions. It does not work with addition or subtraction of fractions. So I'm slowly getting to where I want to be. I've got rid of my millimeters. I've got a 1 on the bottom. That's good, I want that. But I still want a meters on the top. So let's try putting that in here. I've got a meters on the top, a 1 on the bottom, and that's what I want. But I can't just multiply something by meters divided by millimeters. That makes no sense. This conversion factor has to be a fancy looking 1. So we have to come up with an expression on the top and the bottom that, while they may not originally look it, actually mean the exact same thing. If we scroll back to our last page, we can see that milli means 10 to the minus 3. So A millimeter is 10 to the minus 3 meters. These two things, although they don't look it at first, are actually identical to each other. And so this whole expression is just a really fancy looking number 1. And now, to get the answer, I just have to multiply 165 over 1 times 10 to the negative 3 over 1. You might remember that dividing things by 1 doesn't really change them. Now remember, to multiply something like 165 by a power of 10, I write the number, and then I move the decimal according to the exponent. Here the exponent is negative 3, so I move the decimal to the left 3. And I'm left with 0.165. And I can now write that up here. So my answer is 0.165 meters over 1, or I can just write that as 0.165 meters. Now, as a quick aside, some of you might be frustrated with the way I wrote this conversion factor, and you must have said, oh, 10 to the minus 3 meters in a millimeter? No one speaks that way. This is the way people do it. People say there are 1,000 millimeters in 1 meter. And you'd be completely right. People do speak that way. People don't speak this way. And if you use this fraction instead of this one up here, you'd get the exact same answer. And feel free to do that. Just remember that instead of multiplying by 10 to the minus 3, you'll be dividing, because this is on the bottom, by 1,000. So you're free to use whichever of these two you want. Okay, let's look now at the second example. Here we're converting 24 megagrams to centigrams. We're going to follow the same procedure. So we're going to start by writing what we have on the left as a fraction. Next, we're going to write what we want to get to over here on the right as a fraction. And we want to get to centigrams. And along the way, we're going to have one or more conversion factors. Now I look at this thing and I say, I got megagrams. I don't want megagrams. I want centigrams. So let's get rid of those megagrams. Now you might be tempted to put centigrams on the top here because that's what you need in the end. But my problem is I don't really know how many megagrams are in a centigram because that's dealing with two prefixes at once and that confuses my brain. So I'm going to do this in 2 steps. I'm going to just get rid of one prefix and go to grams. And then afterwards, I'm going to introduce the second prefix. So now I need to get rid of this grams up here. So I'll put it down on the bottom, and it'll cancel. And I'm going to introduce my second prefix, centigrams. Now if you look at the units I have here, you can see some stuff is going to cancel out nicely. Megagrams cancels with megagrams. Grams cancels with grams. And I'm left with centigrams over 1, which is what I want, centigrams over 1. So now we just have to fill in the number. Looking at my table back on that first page, or the first side of this page, I see that mega means 10 to the 6. So 1 megagram is 10 to the 6 grams. I also see that centi means 10 to the negative 2. So 1 centigram is 10 to the negative 2 grams. So if I just double check now that my units all work out, I have centigrams on the top here and nothing else. Those two both canceled. So that's good. And I have this one canceled, this one canceled. So just a bunch of 1s on the bottom here, and that's what I want. To calculate this all out, the way it works when I'm multiplying a bunch of fractions together, I basically take all my numbers. So I've got a 24, a 10 to the 6, and a 10 to the negative 2. And the things that are on top, I get multiplied. So this guy's on the top, he gets a multiply. Things that are on the bottom get divided. Now at this point, you can either plug this into your calculator, which would be a good exercise in using your calculator to do exponents of 10, because every calculator is a bit different. Or you can do this in your head and figure out that you're going to get as your answer 2,400,000,000. I'd write that up here if I had the space, but I don't. So our final answer is 2,400,000,000 centigrams. I got the number from here and the unit from up here. So 24 megagrams is the same as 2,400,000,000 centigrams. This last example is a bit different than the top two because we're going to be canceling things out that are on both the bottom and the top. So let's get started. We have 300 kilometers per hour. We need to write that as a fraction, which is pretty easy because per means divided by, or put on the bottom of a fraction. And what we want to get to is meters per second. So we'll write that on the right over here as a fraction. So let's go through this. In my first conversion factor, you may do this in a different order than I do, and that's totally okay. I got kilometers up top. I don't want that. I want to get rid of kilometers. So I'm going to toss some kilometers on the bottom here. And I'm going to go to meters. I know that kilo means 10 to the 3. So 1 kilometer is 10 to the 3 meters. And now I can move on to my next conversion factor. Now I've got hours on the bottom, but I want seconds on the bottom. I don't know exactly off the top of my head how many hours are in a second or how many seconds are in an hour. So I'm going to take a middle step, kind of like we did in the previous problem, and go to minutes first. If I want to cancel out hours, I need it on the bottom and the top. Here it's on the bottom. Up here I'm going to put it on the top. And I'm going to go to minutes. And I know that 1 hour is exactly the same thing as 60 minutes. So this conversion factor is equal to 1, as they all should be. Now finally, I've got this minute stuck on the bottom now, and I want to have seconds. So I want to get rid of the minutes by putting it on the top. And I want to add some seconds on the bottom. I know that 1 minute is the exact same thing as 60 seconds. So I've got kilometers on the top and the bottom. I've got hours on the bottom and the top. I've got minutes on the bottom and the top. And it looks like I'm just left with meters on the top, which is what I want, and a seconds on the bottom, which is what I want. So that's good. Now we just have to plug through the number. I've got 3 times 10 to the 3 because it's on the top, divided by 60 because 60 is on the bottom, divided by 60 because 60 is on the bottom again. And if I plug that all in on my calculator, I'm going to get 0.833 repeating. I can now fill that in with the rest of my work up here. And I'm done. 3 kilometers per hour is the same as 0.833 repeating meters per second. That's it for today's lesson. Thanks for checking it out. I hope you found it useful.